Dear students, welcome to s.mathguru classes. Our main discussion is Cauchy-Euler homogeneous linear differential equation. So last video, how to solve homogeneous differential equation, it was given, and now we consider the remaining problems. Solve x square d square y dx square plus 4x dy dx plus 2y equal to e to the power x. How could we know this is homogeneous differential equation? Because this x power 2 and here order is 2, x power 1 order 1. If we get this type of equation, this is homogeneous differential equation. So solution: for solving this problem, putting x equal to e to the power z. This implies log x equal to z and d dz equal to capital D. We consider d dz equal to capital D. So also it was given, if we have x dy dx, then we can write dy. If we get x square d square y dx square, this is d minus 1 y. It was given in the last video number 1. It was given how to find these details given. Is there any problem? Then you can watch the video number 1. So now we start this. Now this is number 1 we consider. Now 1 implies this will be d minus 1 y. 4, this means dy plus 2y equal to e to the power, this is x means e to the power x means e to the power z. So x equal to e to the power z, we consider this. So this will be y common, d square minus d plus 4d plus 2 y equal to e to the power z. This is d square plus 3d plus 2 y equal to e to the power z. Now auxiliary equation m square plus 3m plus 2 equal to 0. This is m square plus twice m plus m plus 2 equal to 0. So m common, m plus 2, 1 common, m plus 2 equal to 0. So m plus 2, m plus 1 equal to 0. This is m equal to minus 2, m equal to minus 1. We get minus 2 and minus 1. Therefore, complementary function equal to c1 e to the power minus z, c2 e to the power minus 2z. This is our complementary function. Next we find particular integral, because roots are unequal. Unequal means we write in this way. Particular integral, this is e to the power z by d square plus 3d plus 2. This one, right hand side divided by this. Now this will be 1 by d plus 1 d plus 2 e to the power z. We can write this one. This is different types of problem. If simply e to the power z, then we putting d equal to coefficient of z. But here e to the power z, this is difficult to solve. So we write another way. This one, 1 by d plus 1 1 by d plus 2 e to the power z. We write this. And multiplying with this and with this. 1 by d plus 1 e to the power z, 1 by d plus 2 e to the power z. We write in this way. But we know this formula, 1 by d plus a, this is x, 1 plus d 1 by d plus a, this is x, this will be e to the power minus ax integration x e to the power ax dx. We get this our formula, 1 by d plus a x e to the power minus x integration x e to the power ax dx. So using this formula here, a means 1, then e to the power minus z integration x means this one, e to the power z into e to the power z dz. So similarly here a means 2, then this will be e to the power minus 2z integration x means e to the power z e to the power 2z dz. We write this. Now this one remains same, e to the power z e to the power z dz. This is also same, e to the power z. This can be written as e to the power z e to the power z dz. So e to the power z e to the power z e to the power 2z we get. Now we are using substitution method. Now by substitution method, putting e to the power z equal to, suppose u, e to the power z dz equal to, we get du. Now we interchange this. This is e to the power minus z integration e to the power, this we consider u. This is u, e to the power u, and e to the power z dz means du. This means du. We get this minus e to the power 2z integration e to the power z e to the power u, and e to the power, this is u, and e to the power z dz means du. We get du. We get this. And e to the power minus z remains same. If we integrate e to the power u, we get e to the power u. E to the power minus twice z. And using by parts formula, if we directly write by parts formula, u minus 1 e to the power u, we get this. If we directly using by parts formula, we get this one. Now putting the value of u, e to the power minus z, u means e to the power z, e to the power minus twice z, e to the power u means e to the power z minus 1, e to the power z. Just putting the value of u. U means e to the power z, here u, e to the power z. Now this will be e to the power minus z, e to the power z, e to the power minus twice z, and if we multiplying this, e to the power z, e to the power z, minus e to the power z. We get this. And this will be e to the power minus z, e to the power z. If we multiplying this one with this, then plus z minus 2z, we get minus e to the power z. And this one e to the power z. And this will be minus plus e to the power minus 2z e to the power z. we get this one. So these two are like term, this cancel, we get, finally we get e to the power minus 2z e to the power z, and this is e to the power z minus 2 e to the power z. But initially consider x means e to the power z. Since x equal to e to the power z, at the very beginning consider this. So putting the value of e to the power z, this is x to the power minus 2, e to the power z means x. So e to the power x by x square we get. So therefore general solution is y equal to CF plus PI. CF means this one, e to the power C1 e to the power minus z, C2 e to the power minus twice z, plus Pi means e to the power x by x square. And this is we calculate here, e to the power minus z means 1 by e to the power z, and 1 by x, e to the power z means x. And this one, e to the power minus twice z means e to the power z, this is minus 2, x to the power minus 2, 1 by x square we get. So we write here C1 by x, C2 by x square plus e to the power x by x square. This is our required solution, C1 by x, C2 by x square plus e to the power x by x square. This is the final answer. So answer is not so easy but not so difficult. Without practice very difficult, with practice very easy. Solve x square d square y dx square plus x dy dx plus y equal to sine log of x square. This is also homogeneous linear differential equation because this is square, here also second order. This is degree 1, this is order 1. So this is homogeneous linear differential equation. So putting x equal to e to the power z, so log x equal to z, and d dz equal to capital D. So we consider this is number directly 1. Now 1 implies. So x square d square y dx square means d minus 1 y. This is dy plus y sine log of x square. X means e to the power e to the power 2z we get. X equal to e to the power z, this is 2z. So this will be d square minus d plus 1, then y is common, sine 2z log e, this, or we can write d square plus 1 y equal to sine 2z, we get this one, this. Now auxiliary equation m square plus 1 equal to 0, m square equal to minus 1, m equal to plus minus root over minus 1, m equal to plus minus I, this complex. Therefore complementary function equal to a cos z plus b sin z, because I we get our answer. Now we have to find particular integral. Particular integral equal to sine 2z by d square plus 1 sin 2z by d square plus 1. This is trigonometry. If trigonometry is sin and cos, then we putting the coefficient of z here with minus sign. So this is sin 2z, this is minus 2 square plus 1, minus 4 plus 1 minus 3 sin 2z. This is our particular integral. General solution is y equal to CF plus PI. CF means A cos z, B sin z, and Pi means 1 by 3 sin 2z. So this is A cos z means log x. This is log x, B sin of log x 1 by 3 sin 2 log x, or we can write y equal to A cos of log x, B sin of log x 1 by 3 sin log x square. This 2 becomes here x square. So this is the final answer, A cos of log x, B sin of log x minus 1 by 3 sin log x square, and this is our final answer. So these are very easy, very interesting problem. Solutions are also easy. Just you have to remember, if we get this, we write this. If we get this, we write this. You have to remember these things. But if you are facing some problem, then I have given the video number 1. You can easily watch the video number 1. So I hope you are all enjoying. Then if you are all enjoying, then please like this video. If you are new in my channel, please subscribe my channel, click the bell icon. Thank you.